On 33, we're supposed to show that these two are inverses of each other. We've done it a few other ways. I won't focus on the algebra. I feel like the graphing, you could probably handle the table, will be okay. The algebra is where most of the questions end up happening. So kind of the go-to method of algebra is just switch x and y. So if this is f of x, it's really y. So we turn it into an x. And pretty soon we're getting into a really kind of complicated looking thing going on here. So if we want to solve that for y, well, I need to multiply by y plus 5 on both sides. And now I've got y on both sides. Let's see, xy plus 5x equals y minus 1. So really to solve this down, you'd have to move a lot of things around. You have to factor a y out. It could be done, but it gets kind of messy. So here's an alternative, and this I gave you this problem to kind of try to force you to try this other method. We've got this thing that has to be true. If you take f of g of x and you get x back out, then you've definitely shown that these are inverses of each other. So compose the two functions, and if we end up with x as a result, then we have shown that these two are inverses of each other. It doesn't really matter which order we go in. I've already got f of g of x written here, so I can stick to that if I'd like. So I'll just try that. So that means that g goes in place of x over here. So negative 5x plus 1 over x minus 1. And then that was all x, so minus 1. And then for x down here, same thing. All that replaced x, so plus 5. Okay, let's see what we can simplify down. Well, if we're going to subtract 1 from this, then the common denominator would be x minus 1. So since it's just 1, so x minus 1 over itself. And on the bottom, so plus 5, well, we need x minus 1 as a denominator, and we need 5 times that on the top, so 5x minus 5 on the top. Okay, so let me know if you have any issues getting those common denominators, but that's how we would proceed. All right, let's see what we got. Negative 5x minus another one, so negative 6x. Negative 1 minus a negative, wow, that's a lot of negatives going on. That's negative 1. Let me try to just put that up here. Minus a negative 1. So really negative 1 plus 1, that adds up to 0. So that part's good. Common denominator, x minus 1. All right, on the bottom, we've got negative 5x plus 5x, so the x's are gone. Negative 1 plus negative 5, so negative 6. And both are over x minus 1. Okay, flip and multiply next, so negative 6x over x minus 1 times x minus 1 over negative 6. Okay, so let me come on down, I got a little more room. All right, well these x minus 1s are going to divide out to be 0, or sorry, divide out to be 1. So negative 6x on top over negative 6. And that comes out to be x. So that'll do it. The fact that we composed these two together and the result was x, that's proof enough algebraically that these two are in fact inverses of each other. Okay, 81, we're given something that's not one-to-one, so we're going to have to restrict the domain down to make the inverse be a function. I can't remember if I got into this much in the lesson video. And if I didn't, apologies. We usually cover this pretty extensively when we talk about the summer assignment, which we didn't do this year, so I was kind of, I guess I had in the back of my mind we'd already covered it. So just kind of a quick rundown. You should be able to graph this now by hand. We reviewed that a couple sections back. This would be plus 2. Basically, well, we know x squared is a parabola centered at 0, 0. This scoots at 2 to the right. So this is a parabola that opens something like that. And vertex is at 2, 0. All right, the inverse would become 0, 2, and looks something like this. And of course, you can switch points, graph as many as you need to see that. But that's the function, that's its inverse. So the function's not one-to-one, meaning the inverse will not be a function. But if we could split this thing down a line of symmetry, then we can take either half we'd like, and when we make that the inverse, we have a function. In other words, each half of this thing, if we split it right down the middle, each half is now one-to-one. So the inverse would be a function. So let's think about where we would need to do that. That would be at x equals 2. That's that line of symmetry. So for your domain, if x is either greater than or equal to 2, you can, and you don't have to say equal to, but I mean, it doesn't hurt if you have it equal to 2 right there. That would be okay. Or if you did x is less than or equal to 2, that would be the left side. That would be okay. You'd have something that's one-to-one, so the inverse would be a function. So that's what we've got to look at. We've got to restrict the domain down. So we need to give the inverse of this function along with its domain and range. This kind of gets you back to that challenge problem that I assigned. This is why I gave that to you, to make you kind of think about restricting domains. So along with the domain possibilities here, I'm going to put the ranges that would go with those. So if x was greater than or equal to 2, your range would be greater than or equal to 0. And it would actually be the same thing if you did x is less than or equal to 2. So later on, the range will become the domain of the inverse, and the domain will become the range of the inverse. That'll make things a little bit easier. So let's run through and do the math to get this thing solved down, or to get the inverse anyway. So first up, I need to take the square root of both sides. So plus or minus square root of x is equal to y minus 2, then add 2 to both sides. So this is not a function as is, because positive square root would be kind of the upper half like this, negative square root would be the bottom half. You'd have a sideways parabola. So we do need to pick a domain restriction and go with that. So I chose that one. X is greater than or equal to 2. So if you're not really sure which piece of the parabola you have at this point, so a good thing to do is just test a point. So I've already got f of 2 there. Let's maybe try f of 4. Okay, so if I plugged in 4 for x, this is the original. 4 minus 2 is 2. 2 squared is 4. So 4 would be a point on that graph. All right, so what that means for the inverse is that 4 is also on the inverse. So if you want to try to kind of plot out what this piece might look like, 0, 2 would be a point, 4 would also be a point, and we kind of do that. So you're looking at a domain that's going from 0 to infinity and from 2 up. So that would just be the positive piece of the parabola. So if that's the domain that I chose, then my function would be just positive square root of x plus 2. And that would happen when x is greater than or equal to 0. And the range for that part, y would be greater than or equal to 2. Okay. So if you had chose the other part of that, suppose you chose this domain, you wanted to graph this piece of it, you could take the same approach. You could pick, say, 0 for the original here. All right, so that'd be negative 2 squared, so that would also be 4. So 0 to 4 would be a point on the graph, on the original. So if I wanted to graph the inverse for this left side, so 0, 2 means 2, 0 would be on here, and 0, 4 becomes 4, 0. So this would kind of go down this way. I like to do it that way just to kind of get a sense of what's happening. But you could always, again, just switch these around. So if that's the route you went, then your function would be the negative part of the sideways parabola, so negative square root of x plus 2. And your domain, well, the range becomes the domain. The domain becomes the range. So y would be less than or equal to 2. And hopefully you can kind of see that playing out with the green part of the graph. You usually get a few questions about this one because the notation's a little different. You're finding f of g inverse. So the easiest way that I know to do that is begin by finding f of g. So forget about the inverse part for now. Let's just figure out what f of g would end up being. So if we take this function, plug it in for x, 2x minus 5 plus 4, we get 2x minus 1. So the f of x function is 2x minus 1. So that means if we want to do the inverse of that, then let's start with, here's f of g of x. So let's kind of do our normal swap thing where if this is the y value, let's make it x. And if this is your x value, make it y. And then solve. So x plus 1 is 2y, and divide by 2, and that'll do it. So that would be your inverse function, x plus 1 divided by 2. That's really all you have to do to solve that out.